Welcome, boys and girls, to lessons 3 and 4 for our unit regarding multiplication of whole numbers and decimals. This is our 4th unit. In today's lesson, I'm going to show you 3 methods for multiplying 2-digit numbers by 2-digit numbers. And for most of you, this will be a review of something you learned last year, and for some of you, it will be brand new. But I promise you it will be quite handy to learn all 3 methods, and you'll be able to use them for the remainder of the year. The first thing that I want to show you is the pattern for solving the multiplication that you will use actually with all 3 methods. And in this pattern, I want you to remember ones times ones, ones times tens, tens times ones, and tens times tens. If you can remember that, even put it on a post-it, keep it somewhere near you, you'll be able to remember in which order you should multiply each of the digits when you are multiplying 2 by 2 digit numbers. The first method I'm going to show you is called the place value sections model, and this model uses what we call partial products. So that means we're going to look at different place value sections and find the product of each and then add them together. So what does the box have to do with this, or the rectangle? Well, the first thing I want you to notice is that 43 can be written as 40 plus 3. That's 4 tens and 3 ones. 67 is 6 tens and 7 ones. So I'm going to use my rectangle here to represent those as well. If I divide the rectangle this way, the top part of the rectangle here would be where the tens are for 40, 4 tens, and then 3 ones at the bottom. If I'm going across, I can look at 60, and then over here would be 7. 60 plus 7 is 67. Now, once I have my box set up, my rectangle, my area, I can simply multiply each part in the pattern that we talked about before, ones times ones, ones times tens, tens times ones, tens times tens, and then add what I get in each section together to get a final product. So we begin with our ones place times our ones place. So I have 7 times 3, and 7 times 3 meets together at this spot. 7 times 3 is 21. Then I'm going on to multiply ones times tens. So 7 times 40. 7 times 40 would meet up here. So 7 times 40 is 280. That goes into that box. Next, I'm going to multiply my tens times my ones. So 60 times 3. And 60 and 3 meet up right here in this area. So 60 times 3 is 180. Lastly, I'm going to multiply the tens times the tens. So 60 times 40. And 60 and 40 meet up in this box right here. And 60 times 40 would be 2,400. Now all I have to do is add together each of the place value sections. So 2,400 plus 280 plus 180 and 21. I get 118. I add the 1 to the top of the column. 7 plus 1 is 8. And 2. 2,881 is the product there. Okay, I'm going to walk you through another example of this, just a little bit faster this time. So the first thing, again, I remember is I want to break each of the numbers, each of the factors up into their tens and their ones. So I get my rectangle ready, and I want to put together the tens and the ones for my first factor. So the first part of the box represents 5 tens or 50, and down here is 7. And then I set up the rectangle to show 40 and 9. Now I'm going to follow my multiplication pattern that I talked about before. So I start with my 1s times 1s. 9s times 7 is 63. And then I want to go to my 1s times the 10s. So I'm looking at 9 times 50. So that would be 450. The next part would be looking at the 10s times the 1s. The 10s times the 1 here would be 40 times 7. And 40 times 7 would make 280. And then I have the 10s times the 10s, which would be 40 times 50, and that gives me 2,000. Now all I have to do is add up my products, the partial products, 2,000 plus 450 plus 280 and 63, and that gives me a total of 3, and then I have 13 plus 6 is 19. Carry the one, I have 7 in the next column, and 2,793. Okay, here are 2 sample problems for you to try on your own. Go ahead and write down the problems, draw your rectangles, pause your video, and try to solve the problems using this method. Alright, let's go ahead and look at each. We first divide our rectangle to represent 20 plus 8 and 50 plus 4. Now I'm going to multiply our 1s. I'll move him over just to make it a little more clear. Multiply our 1s times our 1s. So 4 times 8 in this box is 32. And then I'm going to go to my 1s times my 10s. So 4 times 20 is 80. And then I'm going to move over and do my 10s times my 1s. So that would be 50 times 8 in this box. And 50 times 8 would be 400. And then I'm going to multiply 50 times 20 in this final box. And 5 times 2 is 10, and we add 2 zeros onto that, follow our pattern. So I end up with these partial products. I can add them together, 1,000 plus 400 plus 80 and 32, and the final product would be 2, and then we keep adding 5 and 1, 1,512. And then we can look at the bottom example. On the bottom example, I can prep my rectangle. I can go ahead and make this 30 plus 2 and 60 plus 4. And I look at 1s times 1s again. So I have 4 times 2, which will give me 8. And then my 1s times my 10s. So 40 times 30 is 120. Then I move over and I do my 10s place times my 1s place. So 60 times 2 is 120. And then 60 times 30. And the last box would be 1,800 or 1,800. I add those partial products together. 1,800 plus 120 plus 120 plus 8. Oops, pardon me, that 8 is a little unclear there. So I have 8, 4, 10, and I'll carry that 1 up, 2,048. The next method we're going to look at is a method we call the expanded notation method. And this method really is quite similar to the place value sections, because we are going to multiply these digits by their place values in small sections and add the partial products together. The only difference is we're just not going to use a rectangle to do it. So we'll go back to our original problem that we had. That was 43 times 67. And I'm going to show you how we still use that same pattern again of 1s times 1s, 1s times 10s, so on. So my 1s times my 1s would be 7 times 3, which we know. and that makes 21. Now, I gave myself a little bit of room and moved that over. You'll see why in just a moment. And then I think of my ones place times my 10. So my 1 in the bottom times my 10 above it. So 7 times the 4 tens above, which is 40. And that gives me 280. And you can see I'm lining up the place values as I'm recording those products. Then I move over on my bottom factor, and I look at the tens below times the ones above. So 6 tens is 60 times 3 ones above it is 180. And then I have 6 tens below, 60, tens times tens, to 4 tens, tens times tens. And that would be 24 and 2 zeros, 2400. I add those together, 1, 8, 8, 2. You see we got the exact same product, 2,881. Now I'm going to show you the expanded notation method again, but I'm going to show you kind of a shorter version of it as we go. I'll show you step by step with each one, and you'll see how the second version might be a little bit speedier for you. So we still want to start off looking at the ones times ones. So the ones in the bottom factor times the ones on the factor above. So that's still going to be 6 times 9, and that will be 54. And again, I make all that room. But I'll do the same thing over here, but this time I'll just record it below. 6 times 9, the ones times the 1, and it's just going to make 54. Then I move on to the ones in the factor below, to the ones on the to the tens on the factor above. So that would be 6 times 40. And that's going to give me 240. I'll do the same thing over here. I'm just not going to write each step out. So I'm looking at 6 tens in the problem, in the factor below, and the 4 tens above. So 6 times 40, 240. Then I know after tens times ones, I go into from ones times tens, I'm going to look at tens times ones. So I want to look at the 3 tens, or 30, and the factor on the bottom, times the 9 ones and the factor above. That gives me 270. But I can do the same thing over here, just do it without writing out each step. So I know that 3 is 30 times 9 ones, 30 times 9, 270. And then I move over and I want to do the tens on the factor below multiplied by the tens in the factor above. So that's 30 times 40, and that gives me 1,200 or 1,200. Over on the other side here on the right, 30 times 40, 1,200. Now I can go ahead and add each of the partial products together on both sides. Beginning with the left, if I add up the ones column, I have a 4 in the tens. 5 and 4 is 9, and 7 is 16. Carrying over to the hundreds place, I have 2, 4, 6, and 1 is 7. And a 1 comes down in the thousands place. And of course the addition will be the same here on the right. I have a 4 in the ones column. 9 and 7 would make 16 tens, so I put down 6 and carry the 1. 2, 4, 6, and 1 is 7, and 1. All right, here are 2 sample problems for you to try using our expanded notation method. Now you can use whichever version of the expanded notation method that you like, either the one that lists each step or simply by writing down the products. Remember, the left and the right side of the screen from the last example. But when I check it, I'm going to use the quicker version to show you the answers. So go ahead and pause your video and try solving these now. Let's go ahead and check your work now. 82 times 34. I have 4 multiplied by 2 is 8. And then 4 times 80 would be 320. Then I move over to the tens place for the bottom factor, and that would be 30 times 2 gives me 60. And then tens and tens would be 30 times 80 would be 2,400. When I add those partial products, I get 2,788. On the example on the right, 3 times 9 would be 27, and 3 multiplied by 70 would be 210. I move over to the tens place on the bottom factor, and I have 50 multiplied by 9 would be 450. And then the tens multiplied by the tens would be 50 times 70 would give me 3,500 or 3,500. Adding those together, 4,187. The final strategy I'm going to show you is called the shortcut or traditional method. And this is probably the method that Mom and Dad learned when they were in school. And this method is still going to follow the same pattern of multiplication in terms of which numbers we multiply in which order, but it'll look a little bit different, and you'll understand why as we go through. But I am going to go back to our initial problem of 43 times 67. And when you do this, you'll see that we will get a product of 2,881, just as we have all along. So I start with my ones times ones. 7 times 3 is 21. I'm going to put down the 1, but rather than putting the 2 down next to it, I'm going to carry the 2 over to the tens place. Now, I still follow the same pattern. I still am going to multiply the ones place below times the tens place above. But now I have this 2 to add into that. So I would take my 7 and 4 and multiply them. 7 times 4 is 28. Because we're not doing the partial products that we did with the other two methods, I'm not going to call this 280. I'm just going to call it what it would be if I were multiplying the basic fact. So I have 7 and 4 is 28, and then I add that additional 2, and that will give me 30. Now, the next step will be to move over, and now instead of multiplying the 7, I'm going to be multiplying the 6. So because I've moved over to a new place value, I mark down a 0 as a placeholder. So that shows me that I have moved from multiplying a 1 to multiplying a 10. I'm also going to help myself out by getting rid of this 2 that I no longer need because it's not connected to the multiplication I'm about to do. So now I'm going to multiply the 6 times 3, and 6 times 3 is 18. Again, this is a little bit different. We're used to saying this is 180, but this is a different strategy, so we just think of it as the basic fact. I put down the 8 and I carry the 1. And so now I have 6 times 4 is 24, and I add in the 1 that I brought up, and 24 and 1 is 25. I add those together, 1, 8, 8, 2, and I have the same product I've found each time, 2,881. I'm going to walk you through this method one more time before I ask you to do it on your own, so please follow along carefully. We start with the same pattern we've been using. The ones place multiplied by the ones place. I start with the factor in the bottom. So I multiply my 2 times 9, which gives me 18. The 8 goes down, and the 1 carries over to the tens place. Now I multiply ones times tens. So the 1 on the bottom, the 2, multiplied by the 10 above, 6. 2 and 6 is 12, and I add the 1 in that I brought up, and that would be 13. Then I put down my 0 marker space to show that I am now done multiplying ones. I'm going to move on to multiplying the tens of the bottom factor. I can get rid of what I brought up the first time, and I go back to my pattern. Now I'm at tens multiplied by ones. So 8 times 9 is 72. The 2 goes down and the 7 comes up. And 8 and 6 is 48, but 48 plus the 7 that I've brought up would be 55. I add those together, and I have a final product of 5,658. Here are 2 new problems for you to try. Go ahead and write them down, pause your video, and try solving them using the new shortcut method. Now we can check your work. And we'll begin with the first problem of 78 multiplied by 26. I start with 6 multiplied by 8 is 48. Put down the 8 and carry the 4. 6 times 7 would be 42, plus the 4 would be 46. I can get rid of this now because I'm done. Put down a 0 place marker and move over. 2 and 8 is 16. Put down the 6, carry the 1. 2 multiplied by 7 is 14, plus 1 is 15. And I get a total product, after adding these together, of 2,028. Then I move over to the next problem. 9 and 4 is 36. And then 4 multiplied by 3 is 12, plus 3 would be 15. I can get rid of this, put down my 0 place marker because I'm moving over. And I go on to the 8. 8 multiplied by 9 is 72. Put down the 2, carry the 7. And 8 multiplied by 3 is 24. And 24 plus 7 is 31. I add those together. And I get a product of 3,276. I can see into the future. A lot of questions. But don't worry. You don't have to be a master of all 3 of these strategies. In fact, we're going to practice tomorrow, and you'll be able to find the method with which you're most comfortable, and then we'll move on from there, trying to get you to become stronger with each one. For now, make sure you know which method you feel the most comfortable with and which causes you to have the most questions so that you can ask your teacher in class. Till next time.